Okay, thank you. Wow. Okay, so now come back. When you perform the dot product, see the answer is positive. It's because the angle theta is less than 90 degrees. So in other words, it's acute angle. This is important, guys. Suppose I do the dot product of the two vectors. I have no idea, but the answer is positive. Positive 5, positive 7, positive whatever. Entonces, you suppose immediately, without determining the angle case, less than 90 degrees. That's acute. That's in the first quadrant. However, when the multiplication, the dot product, the famous dot product, is 0, it's because theta is 90 degrees. And remember the name that we call in calculus 3 for the vector que are perpendicular, que es orthogonal. Okay, orthogonal means 90 degrees. Entonces the angle is right angle. However, when the dot product, the answer is negative. That means and less than 0, que our angle is obtuse. O sea, in the second quadrant, o sea, the angle is in between 90, no equal 90 degree. When the angle is, good question. I want to illustrate this in one example, mister. So somebody asked me, what happens when the angle is 0? It's 180 degree, is acute, obtuse. Sorry. Obtuse is con B. Obtuse means que es in the second quadrant, no? It's in between 90 and 180 degrees. Okay, this is the vector. Entonces somebody said, bueno, you see the angle is 0, what happens with the dot product? Well, maybe it's positive or maybe it's negative, depending si es 0 degree or si es 180 degree. So because, for example, you have parallel vector. Let's illustrate in this example. Look. Let's illustrate in this example. Suppose the vector A, example 2 today. Example 2 today is vector A. It's a vector 4, 6, minus 8. Semicolon, and the vector B is a vector minus 2, minus 3, and positive 4. Entonces, bueno, okay, the same question, compute the angle in between the vector. I have no idea. I am lost, but I remember the formula. The formula says que theta es cosine inversa of in the numerator dot product, in the denominator the magnitude of each vector and multiplication. This is my formula. Okay, let's do it. Entonces, dot product first. Dot product is multiplication. One multiplication 4 times negative 2. This component times this component is negative 8. This component times this component is negative 18. And this component is negative 32. Okay, you're adding everything is negative 58. Bueno, entonces I suppose que es in the second quadrant, ¿no? Pero no, okay, I have no idea. I continue. I compute the magnitude of A, que es square root 4 squared, que es 16. So this component is squared, plus this component is squared, que es 36. Plus this component is squared, you know the negative is inside the square, become positive, is 64. And this is a square root 116. Okay, if you try to simplification a little bit, this is 2 radical 29. Okay, and B, similar. Magnitude B is a square root of each component separate, this and this. Entonces 4 es obvio, ¿no? Plus 9 plus 16. Okay, it's square root 29. Wow. This is an irrational number. Okay, no problem, I understand. Now I go to the formula, and the formula says theta is equal cosine inverse of this, que es negative 58 divided by 2 radical 29 radical 29. And radical 29 times radical 29 is 29. And 29 times 2 is 58. So theta is equal cosine inverse of negative 58 divided by 58, que es negative 1. Y I know very well que cosine inverse of the negative 1 value is 180 degrees. Wow, I discovered que these vectors are parallel. Hello, pero eso es obvio que es parallel. Okay, one fantastic way to do this too long process is, for example, you divide component by component. You divide, for example, 4 divided by negative 2. You copy here in the one corner of the piece of paper. 4 divided by negative 2. Should be equal, si es parallel. 6 divided by negative 3. 6 divided by negative 3. I claim that. Because I'm not sure if it's true or not. And divided the last component, is negative 8 divided by a positive 4. Is negative 8 divided by a positive 4. Remember, I am take care. Okay, I put in the top, for example, the A vector, no? The component, and the bottom B vector. Doesn't matter the order, no? This is obvious, it's true. It's negative 2, negative 2, negative 2. Negative 2, negative 2, negative 2. It's obvious because the B vector is equal minus 2 A vector. Yes or no? So actually, the B vector component, no. A ver, let me see. Negative 2, it's opposite, completely opposite. Sorry, it's A vector. A vector is negative 2 B vector. Let me check it. A vector is negative 2 times negative 2 is positive 4. Oh. Negative 2 times negative 3 is positive 6. Oh. And negative 2 times positive 4 is negative 8. Oh. So this is the relationship connecting this. This is scaling. So the A vector is double magnitude of B, but in opposite direction. That is the reason that the answer 180 degrees is logical. Make sense? Okay. Okay. Valentin says, okay. Okay, just I want to complicate a little bit your life now. So you understand very well this, no problem. We are strong in the interpretation of the dot product. Okay, now I want to propose you one new example, example 3 of today. Okay, let me try to explain the idea for the example 3. In the example 3, we have 3 vectors in 3 dimensions. The vector I want to call U. Okay, component is 1, 1, 3. We have another vector that is B. Okay, the vector B is X, negative 1, 1. Wow, professor, what the hell is that? X is a variable, it's missing. W vector is a vector 1, y, z. So basically, no numerical value. And the vector B, we have 1 unknown, and the vector W, we have 2 unknown. So what's the idea? The idea is find first the value X, Y, and Z, such that to be orthogonal vectors. Okay, so the basic, I need to find the value X, Y, and Z such that these vectors are 90 degrees. I remember 90 degrees is orthogonal and the dot product is 0. Okay, this is the glue. And also, this is my first step. My second step is find the new trihedral. What means trihedral? Trihedral means three vector, chung chung chung, but special, orthogonal, orthonormal vector. What mean orthonormal vectors? Orthonormal basis. Es ortho means 90 degree, and normal indicate magnitude 1. It's a univector. Do you understand the problem? It's easy. Let's do it. You perform the product because the keyword orthogonal indicates us que dot product is 0. So you are doing the dot product. You dot product B. You multiply component by component. It's x minus 1 plus 3. And this should be 0. So I want to guarantee orthogonal. It's obvious, it's easy equation, linear equation, one variable, it's okay. X is equal minus 2. Let's continue. Now multiplication B and W, for example. B and W. You pick one pair, one couple, and you multiply. So when you multiply B and W, we have X. Pero I know that x is negative 2, entonces negative 2. No necessary put x because I know that x is negative 2, no? Now minus y, because it's negative 1 times y, and plus c. Okay, no problem. Entonces I have a question. The question is minus y plus c is equal to. Here I have equation 1 because I suppose that at the end of the problem we have a system of equations because we have two unknown, y and c. Okay, no problem. Now finally, multiplication u, I know, dot product w. Remember u is 1, entonces 1 times 1 is 1. Plus y, nice, because y times 1 plus 3z. S equals